In this video, I'm starting off right where I left off in the last video. My class was coming in. I had to stop. Okay, so what is the chance that 3 engines fail? So we've already found that information here. This is the chance that 3 engines fail. So it's still 4 choose 3 times the probability that it's going to fail, and there are 3 of them, times the probability that this one doesn't fail. So the 4th one doesn't fail. And that is 0.00478. Again, we found that information on the last problem. And when we move our decimal, there's a 0.478% chance that 3 of the engines in the plane will fail. And then another type of problem they can ask, instead of at least, they can say at most 2 engines fail. For this problem, we want to write the probability that x is less than or equal to 2, so at most 2. And this one was the probability that x is greater than or equal to 2. So there's the difference in those 2 problems here. For this one, you can, because we've already, well, actually we can't. So what we're going to do is find the probability of 0 failing. Okay, so that's using the formula. That means 4 do not fail and 0 fail, and it's a 4 choose 0. And the probability that 1 fails, so 4 choose 1, 1 failing, and 3 not failing. And the probability that 2 fail, and 2 don't fail. Once you find all of those, you can add them up to find the probability of at most 2 fail, and you'll find that that is a 99.5% chance that at most 2 of the engines fail. Okay, now we can get into expected value, variance, and standard deviation. These all have formulas that we talked about in the last video, but I can show you it again really quickly, just in case you're joining as new here. To find the expected value, or the mean, we're going to do the number of outcomes times the probability of success. So for our problem here, N times P would be 4 engines, and the probability of success, in this case, remember, success means failing an engine. I picked a crazy problem. Sorry about that. And that is 0.44. So the expected value that 1 fails is 0.44. Okay, that's high. That's kind of terrifying, but okay. The variance is going to be N times P times Q. So the number, which is 4 times 0.11 times 0.89. And that number is 0.392. And then the standard deviation is the square root of the variance. Which we already found, so we just need the square root of 0.392 to 0.626. Okay, I have one more problem for this video, and then I'll set up section 3 in the next video. On a multiple choice exam with 4 possible answer choices for each of the 5 questions, what is the probability that a student should get at most 3 correct just by guessing? Okay, so this is asking, the first question is asking for the probability that x is less than or equal to 3, because it says at most. Now, you don't have to do these by hand. Excel is set up with the data analysis package to do a binomial distribution for you, and so is your calculator. So on this last problem, I want to do it with my calculator with the binomial CDF. Because this is less than or equal to 3, we're going to use a cumulative distribution, which means I'm going to add up 0, 1, 2, and 3. So you can run that in your calculator. Really quickly, I want to write down our given variables. We have 4 answer choices. We have 4 answer choices, but we have 5 questions. So the number of questions is 5. The probability of success comes from the 4 answer choices. So it's a probability that they will get the right answer is 1/4 or 0.25, which means the probability that we'll get it wrong is 0.75. And this is just guessing, right? Okay, so we don't want that. We're going to do menu, statistics, distribution, and then we're looking for binomial. So I went upwards, and we want a CDF. Again, that's because we want to add multiple distributions or multiple probabilities together, just like we did on the engines failing, where we added the different possible probabilities for each engine failing. So if we don't do that, then we just do PDF, but we're going to do a CDF here. Then it asks for the number of trials, which is 5. Asks for the probability of success, which is 0.25. The lower bound is 0 because we're doing less than 3. So 0 to 3 is what we're looking at. So we're going to do 0, 1, 2, and 3. So those are your boundaries, 0 to 3. So that's how it's set up. Binomial CDF is 98%. So 0.984375 is 98.4%. That at most 3 by just guessing are correct. The chance that a student should get at most 3, does it say the same thing? Yeah, I wrote this problem twice, I apologize. The chance that a student should get at least 3 questions correct. We've already done at most 3. So for this one, what we need to do, I'm going to write it in this space because I didn't leave myself enough space, so I'm going to put this one up here. So we have the probability that at least 3, that x is more than or equal to 3. So that means we need the probability of 3 and the probability of 4 and the probability of 5. So you can do that in the calculator as well. It's another binomial CDF, or you can use the formula and find, just like we did on this one right here. I'm going to go ahead and throw it in so we can get it quickly. Now, I can go up here and I can copy this one because it's the same information. Or I can go and put it in again. So I'm going to go ahead and do it again. Hang on, I turned off my computer. There we go. Goodness gracious. So we have menu, statistics, oh goodness, distribution, binomial CDF. Okay, we still have 5 questions. We have a probability of success of 0.25. This time the lower bound is 3 and the upper bound is 5. And that gives us a probability of 0.13, which is 10.35%. Okay. Now, if we were lucky and it said 4 or more, we could have done this information minus 1 and done that. But because they both included 3, we had to be careful. Now, if you had done it by hand, you could have taken that 3 off, got those 2 numbers, and 1 minus, because they have to add up to 1. Okay, in C, the chance that a student should get 2 or 3 answers is. Okay, now I put this problem for a reason. This question is different than these questions. This is asking an or, 2 or 3. So you have to do the probability for 2 plus the probability for 3. So you could do that by hand, or you could put it in your calculator or your Excel, and you would do the probability for each one. But this time, because we're not adding them together, because we're multiplying them together, we are, instead of doing a CDF, we're going to do a PDF. It's a probability distribution function instead of a cumulative distribution function. So just the probability of 1. Number of trials is 5. Probability success is 0.25. And then our value that we're looking for is 2. 26%. And then if we do the same thing and we change it to a 3, we should get the same. Let me change this so that I can multiply these decimals. So we have 0.26 times 0.087. And I'm going to go ahead and multiply those together. It gives us a probability of 0.023, which is about a 2.3% chance that it happens. Okay, the expected number of correct answers is N times P. So our mean is going to be 5 times 0.25. And then my variance and standard deviation, we take N times P times Q, and that gives us 0.9375 for variance, and then for the standard deviation, we can find the square root of that information. .968. Okay, I'll do a short video on how to do it in Excel just in case you need a walkthrough, but it's in the same place where we did the regression. Come back for the next video and we'll talk about the different types of binomial distribution you can have.